So hello everyone, this is MHM Bashir again, and in today's session we will learn a very interesting thing, that is we will work with a Pdb file and we will see what are the contents of a Pdb file, and also we will see if we change the content of a Pdb file how it will affect the structure of it. Okay, so to do so, let's download a Pdb file, and in this case I will be downloading a 3 protein which is known as 4MN8, and that is definitely, you already know that this is the FLS2 protein in complex with FLZ22 and BAC1. That means we have 3 proteins here, FLS2, FLZ22 and BAC1. Let's download it. To download it we have to type PDB, like I said to you, PDB protein data bank, and then we will go to the server and just straight you have to type the protein name or the PDB ID. For our case we already know the PDB ID, which is 4MN8. okay, so let's search for it. So this is the structure of 4MN8. okay, so as you can see it from here, that this is crystal structure of FLZ22, which is a protein, bacterial protein, in complex with FLS2 and BAC1. okay, so we have 3 proteins here, FLZ22, FLS2 and BAC1, and definitely we want to download the PDB file. So here I'm downloading the PDB file. So let's open the PyMol and open the PDB file. okay, and you can do it directly from here, like if you click here get PDB and if you write 4MN8, then it will directly download the PDB file and it will open it for you. See, this is, they directly downloaded it from the server, which is the protein data bank. Well, this is the structure we have got, and we already know that we know what this structure contains, like these structures, ball-like structures and these kind of structures. And if you want to see what these structures are, we already know that at the end of the sequence you see these are the sulfate, okay, and these are the ligand in AG. So we have a lot of sulfate here, and we want to clean this sulfate, because whenever you will be doing a molecular dynamics simulation, you will be needing this file to clean, and we want to do some other jobs. So let's see how we can clean these files and how we can work with this crystal structure. So let's delete this first. okay, delete selection. I'm deleting the selection, and also I can color this with the chain. So here by chain, if I color this by chain, then it will generate 3 different colors. See, this is the main protein, and this is the BAC1, the helping protein, and this is the bacterial protein. okay, so we can see different chains or different components of a structure. For this case we have 3 protein structures here. okay, so let's edit this file, and how we can edit this. So I'm closing the file. So I want to open this with a word processing software, which is WordPad in this case, and I'm advising all of you to open this as in Word file. So first what we will do, we will select Ctrl A and then we will reduce the size of it, because it will help us to do further work. So this is the structure. So the first thing is a header here. So this is the header for MN8, the submission date and the name of the protein. okay, but we don't need this information. So what I want to do, I want to delete all these remarks and things up to the atom. okay, so here our structure starts. So I want to delete the links as well. You see, atom number 1. So up to this I want to delete. So this is atom number 1, this is atom number 2, this is atom number 3, and this is the amino acids, and it started from 26th amino acid, which is serine. Like I said to you, for this crystallographic structure we don't have the sequence from 1 to 25. okay, we don't have that particular structure for this specific protein. And how do you know that this is the FLS2? Because we already know that FLS2 might contain a sequence of from 500 to 700, and might be somewhere within this area, within this range. And you can see that the first one, the first protein is of 784, and I already know that the BAC1 is not this big, so definitely this one is the FLS2 protein, the first one. And the second one, it also started from 26, and let's see the sequence of it. okay, so if you go through the sequence, this is covering more than 200, I think. So as this is 200, that means this is the BAC1, because BAC1 is the second largest protein. If you see the structure, you can see that. And finally the FLG22 is the smallest one. So it started from 68 and then it ended at 85. Okay, and here we can delete all these because these are the ligands file and other ions that we have just seen in the PyMol. So I'm deleting all other things. Okay, so now we have only 3 protein structures here. Well, the next thing you want to do is you want to give a header for all the cases, and for this let's write HEADER. For this one it is FLS2, we already know, and let's go to the bottom of this FLS2. It was around 780. So let's open this. Yes, so here we have the tar, which is the terminal for FLS2, and we want to write header here, and this one is BAC1, we already know. So I'm putting it as BAC1, and then the final one, which is FLG22, and is around 200. So here we have the BAC1. So I'm typing header again, and this is the FLG22. And now just save it. Okay, so yes, I want to save this file, and I want to close this, and then again I want to open this in PyMol again, and let's see what are the changes we have. Okay, so open. So this is the structure we have just edited. So I'm clicking it here. So you see they have selected and they have distinguished the individual proteins. Okay, so you can zoom this one. This is the FLS2 and this is the BAC1, this is the FLG22. So as we selected header, that's why they have given a header for each proteins. Okay, so whenever I'm clicking on any of the proteins, that is hiding that particular protein. Okay, and if you want to see that particular protein, just click it here again, and this is the FLS2 only. And if you want to see both the FLS2 and BAC1, so these are the FLS2 and BAC1, and this is the FLG22. If you want to see only the FLG22, just click here and here, then it will show you the smallest protein for this case. So the next thing I want to do is, like, I want to delete a protein, which is, say for an example, BAC1. I want to delete this particular protein from this structure, from this PDB file, and then I want to dock this BAC1 with this complex. That means we will be having 2 PDB files. One is FLS2 with FLG22, these two, and we will have another PDB file which is the BAC1, and then with the help of a server I will dock these 2 proteins with this particular one. That means I'll be docking FLS2 with FLG22 and or with BAC1. Well, let's do that. We want to press Ctrl A, and then we want to minimize the structure. Now you will have a good shape. Let's delete BAC1. Okay, so from here we can see that this is the header FLS2. Definitely we don't want to delete this one. We want to delete the BAC1 only. So to do so, just find TER, then it will take you to the starting of BAC1. So I am deleting from this portion till the FLG22. Okay, so it's up to 200, we already know. So I have to go to until that part. Well, now we have this BAC1. So I have completely deleted the BAC1. I want to save this again, and I want to see if we could successfully delete the BAC1 or not. So this is the structure, and as we have deleted the BAC1, we can only see these 2 proteins, which is FLS2 and FLG22. That means we have our desired structure for docking. So to get the structure of BAC1, you have to download another PDB file. Okay, because from that PDB file I want to delete FLS2 and FLG22, and I want to get only BAC1 from that PDB file. Okay, this is, I'm giving it name for MN8 BAC1. That means I want this PDB file to contain only the structure of BAC1, though we have 3 protein structures here. To do so, I want to open this in a word processing file again, Ctrl A, minimize the structure, delete everything up to BAC1. So I want to delete up to this part, and let's go at the beginning of this BAC1. So I want to delete the entire thing. So now delete the entire thing and give it a header. Say this one is buck1, this one is buck1, and at the end we have tar. Yes, this is the tar. So let's save it. Now let's open this buck1. See, this is only the buck1. So now we have these two files. One is containing the FLS2 and FLD22. You see, we have only two proteins here, and here we have this buck1. Now we want to dock these two structures. For docking, we have different tools like ClassPro, PatchDock, HADock, ZDock, AutoDock. But for our case, the most easiest one is PatchDock. Okay, so I'll be opening PatchDock, and I will be opening also ClassPro, and I am advising you all to use the ClassPro server, okay, because this ClassPro server is really a useful server. But one thing you need for doing docking, protein docking from this server is you need to get an academic email address, which I believe you already have now. So in PatchDock server, you see, you have to upload your first PDB file, which was this one, 4mn8 dot, and you have to select second PDB file for your case, and just you need to submit the form, okay, and they will do the docking for you. Well, you have to put your email address here. So for this case I am giving mine, and you have to submit the form, and it will send you the result of this PatchDock, okay. And it will take a lot less time compared to the ClassPro. ClassPro will take a longer period of time compared to the PatchDock. So this is the ClassPro server, and I want to give a job name. Say this is FLS2, FLD22, and buck1. So I want to do dock with these two proteins, and you can select server as CPU or GPU, is up to you. But it won't use your power, it will use their power for doing the work. So you can upload the PDB file by clicking here. So the first one is this one, and then upload the PDB file by clicking here, which is the buck1. For now I am keeping it as default, okay, and press dock. So they will do the docking and will send you the email about the docking results. So let's wait for the result. So we have got our result of ClassPro. The interesting fact is we haven't received the result of PatchDock yet, but we have the result of ClassPro. Let's click it here. So these were the previous job that I did in this server, and if any jobs which is more than 2 months old will be deleted automatically. So this job has been just finished, and let's click it here. Here you can see different docking results of this protein. So here they are showing 10 models, but you can see display models up to 28, and they will show you 28 proteins here in this page, okay. And you can download all the structures individually or like all the models all together. And these are the balanced structure, as you can see, and you can see the structure which is electrostatically favored, hydrophobic favored, and van der Waals plus electrostatics favored. All the results you can see, and also you can download the displayed model like I was saying. So I am going through the balanced one, so I'm clicking here. You can view the model score here, and the first one is cluster 0. It has a score of this one -850. For now, let's go to the model part and let's download the first model of ours. So we have got the model here. Let's open this model in the software PyModel. So this is the model we have got, and then if we zoom out, then so one thing you can see that we have FLD22 here, but it is in the same color because they have selected this as receptor and this one as ligand. So that's it. In the future tutorial I'll be talking more about this interaction and docking. And don't miss the live session because we'll be going more detail in the live sessions, okay? Thank you everyone.